Hello everyone, my name is Fabian Vinod and today I will be demonstrating to you my car rental system program. This particular coding or program that I have created allows users to manage these car rental records efficiently. Users can add, view, search and also delete car records, making it a very good tool for a car rental system management. So in this program demonstration, I will cover the program's structure, its functionalities, error handling, and also the design choices of this code. So let's get started. Okay, as you can see here, this is my coding, and I'm going to demonstrate it to you using online GDB. It's an online compiler. So first, let's take a look at the structure of my code. This coding uses a linked list to store a car record. Each record is represented by a car structure, which contains several fields like car ID, model, customer name, the duration of rental, and also a specification structure that holds additional details such as number of seats, color, and also engine size. I choose to use these particular structures to group the related data logically, which helps maintain the clarity and also allows for easy access to each car's specifications. Now, let me show you the main components of the code and how they are organized. So the first function that you can see is the create car node here. This function is responsible for creating a new car node based on user input. It prompts the user to enter details such as car ID, as you can see here, the model, the customer name, the rental duration, and also the specifications, as you can see here. So the next one is add car front, this function. This function allows the users to add a new car record at the front of the linked list. This uses the create car node that I mentioned earlier. It uses that particular function to gather input and also link the new node to the existing list. Next, we can see is add car rare. This is almost similar to the previous function, but this one adds a new car record at the rear of the linked list. It also ensures that the new node is properly linked at the end. And the next we can see is add car add position. This function is to add a car at a specific location in a list. The first one that we saw was adding it to the front, and next we are looking at adding it to the rear of the linked list. And here the user can choose to that particular position, like where they want to add inside the linked list. And next we have view cars here. Yes, this view cars function. This function displays all car records in a formatted table design so that the users can read it easily. So if there are no record, it informs the users that the list is empty. But if during when you run the program, you added a few options of the car, you enter the details, it will come out in the table when the output is there. So next we can see is the search car function. This function allows the users to search for a car by different attributes such as car ID, customer name, model, or color. So if a particular match is found, let's say you add by color of a car, so you add red, and already before you added a car that is red. So when the match is similar and it is found, it displays the relevant details of the car. Otherwise, it will inform the user that no car records were found. And the next one we can see is delete car by ID function. This function is designed to remove a car record based on a car ID provided by the user. It changes the list and links the previous node to the next node, effectively removing the targeted node. I will demonstrate it later in the running time of this code. But so we can look at the last one for now. The last one, the last function in my code is delete front car. This function deletes the first car in the linked list if it exists. If you have inputted the info into this program, it will remove it first. So now we can try run the code and I'll demonstrate it to you. Okay, so you can see here is the menu. Right after you run the program, it will show a menu table like this, including all of the options that I've added. Now, after we run, we can look at the number of lists here. For example, if I select option number 1, add car at the front. Let's see. Okay, so when you add option number 1, it will first ask you a few questions such as the car ID, the model, and the color and the engine size of it. So you can input first. For example, we will include car ID as 001. Okay, we go next, and here it's asking for the model. So let's say it's a BMW 3 Series. Customer name, let's say he's Jacob. The rental of the duration that the customer has rented the car, I can say it is 4. So the number of seats, 5. Color, black. Okay. And then the engine size, here you'll input it in liter, so you can put 3.0. It's not in the CC format, it's like this. So we can go next here. As we can see, after we given the necessary details, it will input a message that the car has been added at the front of the list. This means the link list is formed with this particular data. And next we can see it is showing us the next option, enter your choice. So now you can choose whether you, out of the 3 options that you have to add a car, you can choose which one you want. So I've tried option number 1. Let's go to option number 2, which is add car at rear. Option number 2. So again, we can go through this. This ID I would like to give 002. So the car model is Toyota Corolla. Customer name is name. Duration is 9. Number of seats 5 again. Color. Now we can go to black. The size of liter 1.4. Here. Now it shows a message that the car has been added at the rear and not the front, because this is the second option that we are going through. And now this particular detail that you have entered, it is been included inside the storage of this particular program. So it is already formed inside the linked list. So when you try to display the table later, we can see how it works. Now we try to add car at a specific position. Let's look what are the things that we will ask the user. 3C. Here, as we can see, it's asking for enter position to add car. Starting from 1, it's directing the user at, like, they have this freedom to choose which position they want to add that particular car. So let's say 3. Now, again, we have to enter car ID, a different one. Let's just give 003. Car model is, let's go for Ferrari. Ferrari Enzo. Customer name, Johan. Until duration 1. Okay, number of seats in Ferrari can be 2. Color, red. Liter 4.6. Okay, now it has shown us the another message, or notified us that this car has been added at position number 3. This position is what we chose, or the user chose as a specific position and not a standard position that is given by the program. No, this is chosen by the user, which is 3. Now we can go for option number 4, which is view all cars. Now we can look at the table that is formed by the linked list. Here, as we can see, the table is very nicely formed. You can see it has arranged 1, 2, 3, BMW 3 Series, the customer name, the days of rental, the number of seats, the color, and also the engine size. This is the table. As I've inputted a total 3 cars that are different. Here is the table that we can see. So this ensures that the user is able to look at the table or the data inside this particular program. They can add as many cars as they want and then proceed to use this system. Okay, so now let's look at option number 5, which is search for a car. As we can see, after we input 5, it's asking us like in what ways we want to search that car. It can be by the ID, it can be by customer name, it can be model, it can also be color. So let's be creative a little bit. We can go for red. Okay, so now after input, it will check the table whether there is this particular car detail that syncs with what the choice has been. So now my choice for search is red. So it will check the table. Is there any car that is red in color? So I've inputted, let's see, red. Now, as you can see here, I've inputted red, and earlier on there was red inside the linked list table. Inside the data, there was a red color, which was the Ferrari. And since this particular data that I inputted, red, it has synced with the table, so it will output the message that the car is found. See? And later on, it will display the particular car's detail, the car ID, the model, the name, and every detail. It will output to the user. Next, we can look at option number 6, which is delete car by ID. In go 6. Okay, now since we have 3 different cars in our data or linked list table, and we can select a particular car ID. Let's say we want to delete car ID number 1. So we can enter, but ID we cannot simply put 1, but because earlier on we added the ID particularly as 001. So now we can try 001. We're going to delete it, enter. It will show the message that the car has been successfully deleted. So now inside the data of this program, there are only 2 cars because we have already deleted 1. Okay, now we can proceed to number 7, delete front car. So since the first car is deleted, now the one in the first place in the table would possibly be Toyota Corolla. That would have moved on to the first place. And so let's try to see again by going to option number 4 to view the table. See, as we can see here, Toyota Corolla is at the first spot inside the table. So now we can proceed to option number 7. Let's go 7, which will delete car which is at the front. Now the one at the front is Toyota Corolla, so now we can delete it. It will again prompt to the user that the front car has been successfully deleted. So now even if you try to view all cars again, it will only show us the Ferrari Enzo because only that one is left. So the last option that we have now is option number 0. If the user has completely used all of the options that are available, they can choose to exit the program by clicking 0. Okay, that's all. It's showing an existing program. So I'm very happy that program has worked very well. One of the important aspect of this program is error handling and also input validation. This program that I've made, it includes checks for valid input for car ID, rental duration, and also other options that I've included. If the user enters invalid data or any data that is out of range value, the program will show the user that it is an inappropriate data input. Let's say if the user attempts to add a car with a negative rental duration, then the program will reject the input and it will ask the user again for a valid number. So in conclusion, my car rental system is designed to be user friendly and also efficient because it allows the users to manage the record with ease. There is no difficulties at all. So the use of this linked list provides flexibility in record management for my system. So if I were to expand this project further, I could also consider implementing a database solution for good storage and also adding user authentication feature to enhance this program. But now we are not looking into that. So for this particular lab report, I think I'm happy with the outcome. Okay, that's all from me, madam. Thank you very much.